Hello, my name's Brian. I'm an Agile management consultant, and earlier last year I left the smoke of old London town and headed north. Welcome to glorious Yorkshire. Now I'm using the Agile management practices to get stuff done around the house. We have some grand plans on the roadmap. But plans are nothing. We've actually got to get stuff done. But if agility is just a bunch of silly words to you, then don't worry. Stick around. Just enjoy watching stuff getting done. Easter, a distant memory, and my forecast for when the Lean 2 would be completed by. We can retrospect on what went wrong later, but for now, there is still more fabrication to be done. A quick recap. We're building a timber-framed Lean 2 here against the garage to protect the lawn tractor from the Yorkshire weather. Previously, we've gathered our requirements and constraints. 218 centimetres, 86 inches. With those requirements and constraints, we were able to put together a design. And in order to check the design works, we prototyped some of it. Oh, and that. Oh, that is so nice. That's really good. The prototype worked, so now we just need to get on and fabricate it. Agility works best when you specify the challenge, the problem to solve, and then let those with the expertise solve it. The challenge is the sole plate. 100mm by 44mm by 2.8 meter piece of oak that forms the base of the tongue and groove wall on the lean-to. Which means I have the challenge of just how do I cut the sole plate from those larger timber beams. The problem we have is that there is a significant bow in this beam. I need to somehow get it straightened out. As you can see, between the edge and the laser line, getting quite wide. And then we're back in at that corner. Can I get that steel out is the question. So the steel is a lot straighter than the beam. It's not perfect. It's maybe a mil or two off at the midpoint there. And then we're back to just grazing there at the end. I flipped the beam round and we're going down that side. That is pretty much riding the edge all the way down, and there it is. That's looking good. The plan is to use the angle iron as a straight edge, and we validated it is fairly straight within tolerances. Run the router down the side of the angle iron, and that will create a little rabbit just through here that we can then take as the straight edge, and we can start pushing down from there, using more and more router bits, ever longer. There are many ways to get a straight piece of timber, some mechanized, some manual. Some I can do with the tools I've got, some I can't. I could have planed a flat surface, but the volume of material to be removed and the area over which I needed a flat surface, hand planing wasn't appealing. I could have placed the timber in a box and used a router on a sled to flatten the top. I even have such a box buried in the timber stacks, but unburying it for a single job wasn't appealing. The option rising to the surface was straight edge and router. This is set-based design at work. Assess the options to solving the problem, even if that assessment is in your head. The router creates a straight face to use as a reference. From there, I can push further down with template following bits, but they will only reach halfway through the timber. I'll need to use a trimming bit from the far side, but there is more material than the trimming bit can handle. So I turn the timber and plane away excess material using a powered plane. Turning the material again, I can use the big router with a long trimming bit to pick up the previously machined straight edge, and it trims back the last little bit. 3 steps to get to a straight edge. Acceptable for a one-off operation. Another approach would probably win if this had to be done repeatedly. The straight edge allows me to set up the circular saw to cut the 44mm width of the sole plate. 1 pass on each side to get the depth. I actually cut oversize because I know that the cuts will be messy. Whilst the cuts are perpendicular to the face, because the opposing faces of the timber aren't necessarily perfectly parallel, the cuts won't be exactly coplanar. There will always be a lip that needs machining off. With the sole plate free of the beam, I can bring the oversized piece down to width on the thicknesser, removing any messiness in the process. It's just a simple piece of timber. But there's a lot of problem solving that goes into just getting a piece of timber, and the inevitable trade-offs. I traded my time for money. I could have got a timber supplier to machine the piece for me, but I would have paid them for doing the problem solving. There are other benefits beyond the obvious, namely that I've learnt along the way. What works, what doesn't. How to leave enough spare, but not too much that time and material is wasted. Inherent knowledge that if I can remember it, can be utilised next time. So the intent was to cut this piece of timber down further to create the internal sole plate, and any spares, use them as facings over the roof. The first attempt at cutting the sole plate ended up a bit of a mess. Cuts are a lot deeper than I was expecting. Therefore, I'm tempted to try again with this piece, which has a fairly clean edge, and I can validate that, and machine that back if necessary, to get a second one and use the first attempt cut down as the internal sole plate. Sometimes you just have to do something once to learn how to do it. The experiment proves insight and knowledge. We would all love it to work first time, but when problem solving, sometimes you just have to spend time and resources on solving the problem. So, we're cutting the sole plate a second time. It's quicker this time because we've learnt from the last time. The error margins on the cuts are slightly bigger. Then the thicknesser can bring everything down to the right dimensions. This time we have a nice clean piece of timber. The final piece of hardwood is ready. The last job is to machine the softwood timber.
But whilst I was coming back from the local builders merchants with the relevant timber, the car started beeping viciously. Error code 4 on the dashboard, temperature rising. I managed to nurse it home the last mile and a half. Now I have to prioritize mobility over equipment storage and shelter. The lean-to is going to have to take a back seat whilst I work out why all of the coolant has disappeared from the engine. But that is a job for next time.